Hello everyone, I'm Aleksandr Sakhnevych from MODULARITY and from the University of Federico II of Naples. Today I will talk to you about the RIDEsuite, that is a real-time multi-physical modular time solution from the MODULARITY. Ours is the scientific background of the Vehicle Dynamics Research Group from the University of Naples. Ours is a holistic view in the tire modeling. But as you know, for every complex problem, there is a solution that is clear, simple, but it's wrong. So what we want to do is to design the modularity, physics, and real-time in the same solution, able to offer the opportunity to our partners to work with the same solution in offline for the standalone applications and real-time, and to be compliant to any interaction model and sim environments, and to offer the modularity dependent on partners' requirements and needs on their specifics. Our main aim is to provide particularly responsive tools which could be employed both as offline simulation tools and both in real-time environment. Typical workflow consists of three phases. One is the gathering and the processing of the input data that can be from both outdoor acquisitions or indoor test benches. Once everything has been gathered and processed, we can adopt tools, specific tools designed to calibrate and to process the data and to understand in which cluster we can identify different components of our multi-domain, multi-physical data. And this helps adheLAB, and it helps to discriminate between dynamics, thermal, wear, degradation effects in order to calibrate and to validate our RIDEsuite, that is a multi-physical modular tire solution. RIDEsuite solution represents modularity, physics, and real-time. It mainly consists of four parts: thermoRIDE, adheRIDE, RIDERIDE, and wearRIDE. thermoRIDE is a thermal model. It involves and uses vehicle input from data or test benches, so time histories, time signals. It also is characterized, parameterized thanks to the thermal parameters and footprint analysis. Both are non-destructive tests, and it is able to provide locally tire temperatures, energy contributions, and inflation pressure in output. adheRIDE is our magic formula EVO-based model, which is able to take into account of wear, pressure, temperature, and degradation. 3D-RIDE is our multi-contact solution that is able to give the possibility to MF-EVO to work in a frequency domain to extend its applicability also for the durability part. And finally, the wearRIDE is a wear model which is able to take into account of the road, compound, and the local temperature, pressure, velocity distributions in order to understand in output what's going on in terms of abrasive and chemical degradation. In detail, we start from the input collection that could be provided thanks to outdoor acquisitions or indoor, but also from the data from the vehicle models, estimators, and so on. Indoor testing is used for the parameterization of our models, in particular TechScan, laser diffusivity test, VESEVO non-destructive testing, or CLIT tests, and all of them are non-destructive and are used to characterize our models. The multi-physical calibration for thermoRIDE typically involves the validation with TPMS, with IR sensors, both internal and external. And here you can see an agreement between the outputs of the model and the acquired points, both for a car or a bike. Multi-physical calibration, starting from the data acquired and processed by the thermal model on the wear model, then can be used by the adheRIDE for the calibration. And as you can see here, the corner stiffness and the grip can change a lot and can vary a lot with temperature and pressure, as well as with thread thickness and a level of thermal cycles. Here you can see also how the tires then modify and can modify the vehicle's performance as well as the tire's performance, and everything can be used and should be used both in simulation, in offline, or on driven loop. Multiphysical calibrations also involve the wear model, and here you can see how the compound can modify a lot its characteristics in terms of loss factor with mileage, as well as the abrasive wear modifies the thickness and as well the stiffness and the grip. Our 3D RIDE is a solution for extend the applicability of magic formula also in a frequency domain, and here you can see the validation between the multi-contact 3D RIDE approach and the classical magic formula single contact point approach. In order to validate and to calibrate the adheRIDE, that is our RIDEsuite main solution, we start from processing our dataset thanks to adheLAB, that is a processing tool that can be flexible to any partner's proprietary dataset and can provide a robust identification of the model params, smart detection of the physical data, not non-physical outliers, and so on, identifying robustly the dynamics of the Passeca and extending it thanks to the thermal and the wear parts. The output of the thermal model can be used to enrich the regional dataset, comprehending the kinematics and the forces estimated on board of the vehicle, measured or on the dedicated test bench. And what we can see from here is how the pressures, temperatures of the compound of the carcass can deeply affect the tire characteristics in terms of grip, stiffness, or hysteretical part. Our thermal model consists of more than 6 layers along the thickness, takes into account of the main thermal effects as external convection, road conduction, and friction. Cell is strain energy loss inside the bulk of the material that depends on the car characteristics, on the belt and the compound, inner air, and finally the rim that it can also take into account of the radiation of disk or any else convective effects. Once the thermal model has been calibrated, its output can be used then within the adheLAB model, coupling the thermodynamics with the dynamics of the tire and extending its applicability for each condition in terms of temperature and pressure. The final stage involves the wear model, which is calibrated and validated on the outdoor-indoor data once the thickness variations have been collected. In this case, what normally is done is to model the degradation part in terms of the modifications of the loss factor or tan delta with aging effect, and also take into account of the thickness reduction and its variation on and its influence on the thermodynamics. RIDEsuite is a multi-physics simulation platform. It mainly consists of 3 models, which is dynamics, thermal, and wear, and it's extended to take into account of the original Passeca model in temperature, pressure, and wear domains. RIDEsuite solution represents the simplest way to couple the vehicle model and the real profile in order to achieve the maximum performance and to allow our customers to work in the same model in both offline and online. The simplest way to employ the RIDEsuite solution is to use it as a standalone application, which allows to conduct a lot of analysis, studies the dependencies from the inner temperature, wear, ride roughness, thread viscoelasticity, or to study the warm-up, heat exchanges, thermodynamic optimization analysis in all the phases of the runs. During the last year, we had a chance to conduct a lot of offline simulations using our desktop solutions with coupling our model with REALTIME from ViaGrade, Adams from MSc, MATLAB and from MathWorks, and understanding how the setup or the vehicle setup or the tire setup could modify the vehicle overall performance or the driver's control. In this case, what you can see is the case study offered from Mercedes DAS 2020, where we had a chance to analyze the possible impact of the DAS solution on the overall vehicle performance. Another way to use the RIDEsuite solution is to employ it within the LAPTIME optimization tools. During the last year, we have also coupled our model with the REALTIME, MATLAB, and other tools which have enabled us to study to understand what could be the variations of the vehicle, of the tires, and even of the boundary conditions of the tracks in terms of temperature of the air, the temperature of the track itself, on what could be the vehicle performance, the driver's inputs, or even to understand what could be the optimal setup for each condition and for each driver. You will never see any difference between the real-time in online simulation and the offline simulation. The enhanced feelings from the subjective analysis conducted in the driver-in-the-loop environments will be of the same quality and the same accuracy you have already achieved in the standalone applications or desktop offline simulations. Furthermore, multi-contact and low-speed ride modes allow you to enrich your feelings and to allow you to employ the magic formula even in particularly critical situations. Here you can find our references that represent some of our background that has been used within the modeling part and multi-physical representation of the tire. Thank you a lot for your time, and please don't hesitate to contact me.